Hello, this is Mr. Miller here, and it's time for video number 57, Introduction to the Distance Formula. This is the crazy distance formula right here. You can see it, and we're going to learn where it comes from. Its goal, or the purpose of the distance formula, is to calculate the distance between any 2 points. So I'm going to see where it comes from. Okay, so let's start with something we're very familiar with. So we were doing in class, we have 2 points right here and up here. We want to find the distance between these 2 points. That would be the length of this line segment between them. So the way we do that when we have a grid is just to make a right triangle. We can solve this. So we're going to go that way, and we're going to go down, make a right triangle, what's supposed to be a right triangle, and use the Pythagorean theorem. This side is 1, 2, 3, 4, 5. This side is 1, 2, 3, 4, 5, 6, 7, 8. Here we go. And this is C, the hypotenuse. So the distance between them is the length of the hypotenuse. So 5 squared plus 8 squared equals C squared. That's 25 plus 64 is C squared. This looks very familiar. And we get C squared is 89. So C is the square root of 89. Okay, that's old news, but it's just using the Pythagorean theorem to find the length of the hypotenuse. Okay, now let's try something a little bit new. Let's take another step here. So in this diagram, we don't have the grid anymore. All we have are the points. Okay, so we can still kind of draw a triangle here. All right, now, even though I don't have a grid, I can still use the coordinates of the points to figure out how much x changed by and how much y changed by. The x coordinate of the first point here is 3, right here. And then as we go over to the second point, we go to x equals 9. So we see that the x coordinate went from 3 to 9, so the run is 6. Remember, the run is kind of like the change in x. The horizontal change is 6. It starts at 3, ends at 9. The vertical change is a change in y coordinates. So we start at 4, and we end up at 7. So we must have went up 3. Okay, so now we have the two legs of the right triangle. The bottom leg is a change in x. The top leg is a change in y. We can use the Pythagorean theorem. So c squared is equal to 6 squared plus 3 squared. So c squared is equal to 36 plus 9. So c squared is equal to 45. So c is square root of 45. And this time that simplifies. So we can pull out 9. So it's square root of 9 times square root of 5, which is 3 square root of 5. Done. Okay, so this distance is 3 square root of 5. Really, all I needed were the coordinates. Let's look at another example of this. Here we go. This time I have the triangle already drawn. I want to find the distance between 2, 5 and 10, 12. So, let me turn my pen on. Okay, so we got to find the change in x. So, x coordinate starts at 2, and the x coordinate of the second point is 10. So the change in x is 8. Okay, and then the change in y, how much did it go up? All these points down here have y equals 5, and we're going up to y equals 12. 12 minus 5 is 7. We really don't need it, but we can figure out the coordinates of this point. This point has the same x coordinate as this point up here, and the same y coordinate as the first point, 5. So the reason why I did that is we can see going from this point to this point, x, the only change was x went up by 8. And then going from this point to up here, the only change was y. It went from 5 to 12, which is 7. Okay, so this right here is the change in x, like the run, that's the rise. And now we can use those two values to do the Pythagorean theorem. Okay, so c squared is 8 squared plus 7 squared, which is 64 plus 49. So c squared equals, I think it's 113. So c equals the square root of 113. All right, that's the distance between the 2 points. Now, let's do this once and for all. If we do it with some generic points, x1, y1, x2, y2, those just represent the coordinates of the first point and the second point, we can derive a formula. All right, so drew in the triangle here. And remember that the bottom is how much x changes by. So the bottom is the second x coordinate minus the first. So this right here is x2 minus x1. Okay, the change in x. The second x coordinate minus the first. And right here, how much did we go up? Well, it's the change in y. It's the second y coordinate minus the first. This is how we did it when we had numbers. And now I'm just writing a formula. Okay, and we want to know the distance. This time I'm going to call it d. Before I call it c, because that's what we usually use in the Pythagorean theorem. But I want d for distance now. Okay, so here we go. These are the two legs. So a squared, which would be x2 minus x1 squared. That's this side squared, plus this side squared, has to equal the hypotenuse squared, which is d squared. Wow. Okay. Now, all you gotta do is take a square root, and I have solved for d. So if I take the square root of all of this, we have square root of x2 minus x1 squared plus y2 minus y1 squared equals d. And normally we write it this way. We put d first. So I'm just going to flip the equation. It's a big square root. Now, we'll be practicing this a lot. After you practice it a lot, it kind of really sinks in and makes sense. Now it looks really, really complicated. It's really not that bad. Okay, so that's a formula for the distance between 2 points. We can just plug into the formula. So we don't even need a picture now or to draw triangles. We can just put the coordinates of the points in here. So we're using like x1, x2, y1, y2. That's kind of what we used for slope. When we see them here in the distance formula, we'll see them in the midpoint formula. Okay, so we're going to do 3 quick examples of using the distance formula. We got it right here. So remember that this first point is x1, y1. And the second point is x2, y2. And so we just have to plug into this formula. Okay, so d equals square root, big square root, it's the square root of the whole thing. x2, the second x coordinate minus the first one. 7 minus 4 squared plus the second y coordinate minus the first. So I'll just put in exactly as in the formula. Now, a little secret in how to evaluate this. I would figure out what the inside is first. You can put the inside into your calculator and then take the square root after you've simplified it. So you could put all this in your calculator to figure out what it is and then take the square root. I'm going to do it a little bit step by step. 7 minus 4 is 3, squared is 9. 2 minus 9 is negative 7, and if you square that, you get positive 49. So if you figured out the inside, you just get the square root of 58. All right, I don't think 58 simplifies. So that's the distance between those 2 points. So really, it's just a matter of getting used to evaluating this formula. Again, I would break it up. Figure out what the inside is first, then see if you can simplify it or take the square root if you want a decimal. All right, we got 2 left. Let's do this. So square root, big square root. We have x2 minus x1. 9 minus a negative 2. Don't drop the negatives. It's 9 minus a negative 2 squared plus we have negative 5 minus 7 squared. Okay, so d equals big square root. So I'm going to simplify part at a time. So 9 minus negative 2 is 11. Squared is 121. Plus negative 5 minus 7 is negative 12. Squared is positive 144. So we get d equals square root of 265. Now, that might simplify or it might not, but right now, I'm not worried about that. So I'm just going to leave it like that. Okay, it's kind of a big number. If it's small, I would simplify it. Since it's big, I'm not going to worry about that right now. That's not the main issue. All right, so let's do this one. So d equals big square root x2, which is 7 minus x1 squared plus y2 minus y1. And I get d equals the square root of. I'm going to put all of that in my calculator and see what I get. All that amounts to 689. So square root of 689. Now, we can start seeing what perfect squares go in there. But that's a lot of work. This time, I think I'm just going to find the decimal. And I get about 26.25. So that's approximately 26.25. I'm okay if you would have left the square root. Okay, that's the distance formula. So if you watch this, you got a little heads up on what we're doing in class. All right, so for your general assignment, we're out of time, so let me describe it very quickly. You're going to do what we did on the last slide. You're going to plug these points into the distance formula and find the distance between the points. So between A and B, and then C and D. Okay, so show your work. Show me the big square root, and then simplify the inside, and do the same for the second one. Good luck.